Here are three little mini examples of tinkering with polynomials. We're asked to simplify all of them, which means clean house. Get these things tidied up as much as possible. So combine like terms, meaning combine terms that have the same exponent on the variable, cancel as much as you can, and so on. So for this first one, we just have a lot of clutter in terms of individual powers of t. And so the best we can do here is just gather the common exponents, the terms from the common exponents. So let's start with this 5t to the fourth, and let's see if there's any other t to the fourth that we can combine it with. And nope. And so the 5t to the fourth just stays put. Now, if we go down from the exponent of 4, maybe now we should look for 3. So let's look for t cubes. Well, there's no t cubed on the left, but aha, there is one on the right. And so let's put that one in place next, because being orderly beings, we like to have our exponents follow a pattern, and that pattern is usually to decrease by 1 as you go down the polynomial. The leading term is signaled by the highest exponent. All right, let's look for t squareds. Aha, here's a negative 2t squared, and then plus a positive 2t squared. And so these two terms cancel each other out. So I guess I could write plus 0t squared just to fill the spot, but I won't do that because it's 0. But let's remember that there could be a t squared in different problems. Are there any terms that have just t to the first? Nope, 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 nope. Aha, there's one. There's a 7t. And then let's look for constants. Negative 17 plus negative 2. That's negative 19. That's as good as we can do with that expression. We can't factor anything. There's no more combinations to find. Now, in this quotient, the cleanup here is going to come from some cancellation. We certainly can't add these two terms together because they have different exponents on the variable, so they're stuck the way they are. But maybe we can do some factoring of that numerator, and let's see, both of these terms have a 10. So let's factor out a 10. Both of these terms have at least a y squared, so let's take out a y squared. When we take out a 10 and a y squared from this first term, we're left with 2 times y. And just double check, this multiplication, 10y squared times 2y, is 20y cubed, and that's the original term. And then, from this second term, the minus sign's hanging out, we've factored out the 10, that's out, and the y squared is also factored out, so hey, just a 1 is what's left over. And now we can divide this by 5y again, and now we can look for some cancellation. This 5 will cancel into this 10, leaving 2 behind. This y will cancel with one of those y's, so the net result is 2y times 2y minus 1. And then finally, in this third one, we're asked to produce an expression that shows the full area of this rectangle. Well, the area of a rectangle is its length times its width, so that's x plus 4 times 2x minus 5. And perhaps we don't want to see that in its factored form. Maybe we're being asked to show it as a full polynomial, kind of like up here. And so here we have to multiply it out. And so when we multiply this out, you have to remember that everything in these parentheses have to multiply against everything in those parentheses. So just find all of the potential pairs. So this x will multiply that 2x and that negative 5. And this 4 will multiply that 2x and that negative 5. So there's going to be 4 terms when we multiply this out. So the x times the 2x gives us a 2x squared. The x times the negative 5 will give us minus 5x. The 4 times the 2x gives us an 8x, and the 4 times the negative 5 gives us negative 20. So that's what we get when we distribute the multiplication out. And now we notice housekeeping to do. We can combine those two middle terms. So we have 2x squared. The net here is a positive 3x, and then minus 20.